The world of genetic engineering was shaken in 2018. A Chinese scientist, Dr. Jiankui, announced the birth of twin girls. Their genes had been edited using CRISPR/Cas9 technology. He aimed to confer resistance to HIV. The scientific community reacted with shock and condemnation. His experiment was a dangerous breach of ethical boundaries. It raised profound questions about the future of gene editing. Dr. He's actions sparked international outrage and debate. The scientific community grappled with the implications of his experiment. The use of CRISPR/Cas9 on human embryos was unprecedented. It raised concerns about unintended consequences and the potential for genetic enhancements. The Jiankui affair became a turning point in the debate about gene editing and its ethical limits. This essay explores the Jiankui saga and its implications. It examines the scientific methodology, the ethical violations, and the potential risks of unregulated gene editing. The essay also highlights the need for stringent international regulations to guide future research and applications of CRISPR/Cas9 technology. The Jiankui affair serves as a stark reminder. The power of gene editing technology demands careful consideration. It necessitates a global dialogue on its ethical, social, and legal implications. The future of gene editing hinges on responsible scientific conduct and robust regulatory frameworks. Dr. Jiankui chose the CCR5 gene as his target. This gene plays a crucial role in HIV infection. It acts as a doorway for the virus to enter human cells. A naturally occurring mutation, CCR5 delta 32, provides resistance to HIV. People with this mutation have a significantly lower risk of contracting the virus. He aimed to replicate this mutation in the twin girls. He used CRISPR/Cas9 to edit the CCR5 gene in their embryos. The goal was to disable the gene and confer HIV resistance. The experiment was shrouded in secrecy, with little transparency about the methods and procedures used. The choice of CCR5 as a target was not arbitrary. HIV/AIDS remains a global health crisis. Finding a way to prevent its transmission is a major scientific goal. However, gene editing in embryos raises significant ethical concerns. It alters the germline, meaning the changes are passed down to future generations. The potential benefits of HIV resistance had to be weighed against the unknown risks of gene editing. Dr. He's experiment ignited a debate about the ethical boundaries of genetic interventions. It highlighted the need for caution and careful consideration when manipulating the human genome. Dr. He's experiment, while ambitious in its goal, was deeply flawed in its execution. Multiple scientific shortcomings undermined the validity and safety of his approach. These flaws raised serious concerns about the efficacy of the gene editing and its potential for unintended consequences. One major flaw was the risk of off-target mutation. CRISPR/Cas9, while a powerful tool, is not perfect. It can sometimes cut DNA at unintended locations. These off-target cuts can disrupt the function of other genes, leading to unforeseen health problems. Another concern was the issue of mosaicism. Mosaicism occurs when gene editing is not uniform across all cells of an organism. In the case of the twin girls, some cells may have the edited CCR5 gene, while others retain the original gene. This patchwork of edited and unedited cells can lead to unpredictable health outcomes. Furthermore, it is unclear whether Dr. He achieved the intended complete disruption of the CCR5 gene. Partial or incomplete editing could result in a modified protein with altered function. This could have unforeseen consequences for the girl's health and susceptibility to other diseases. The scientific community criticized the lack of transparency and rigor in Dr. He's experiment. The absence of peer review and independent verification made it impossible to assess the validity of his claims. The flaws in his approach underscored the need for caution and ethical oversight in gene editing research. Dr. He's experiment was not only scientifically flawed, but also deeply troubling from an ethical standpoint. His actions violated fundamental principles of informed consent, scientific integrity, and the protection of human subjects. These ethical breaches had far-reaching consequences for the field of gene editing and for society as a whole. One of the most egregious violations was the lack of informed consent. The parents of the twin girls were reportedly misled about the risks and benefits of the experiment. They were not fully informed about the potential consequences for their children's health or the possibility of unintended genetic changes. Moreover, Dr. He's experiment raised profound questions about intergenerational genetic consequences. Germline editing, by its very nature, alters the genetic makeup of future generations. The long-term effects of such alterations are unknown and potentially irreversible. The experiment also highlighted the slippery slope argument against germline editing. Critics argued that allowing gene editing for disease prevention could open the door to genetic enhancements. This could lead to a future where parents select desirable traits for their children, exacerbating social inequalities and undermining human diversity. The ethical fallout from Dr. He's experiment was swift and severe. The scientific community condemned his actions, calling for a moratorium on germline editing. The case sparked a global debate about the ethical limits of genetic engineering and the need for stringent regulations to prevent future abuses. Section 5. Legal repercussions, a prison sentence and beyond. Dr. Jiankui's actions had swift and severe legal consequences. His experiment, conducted in secrecy and without proper authorization, violated Chinese regulations on human genetic engineering. In December 2019, a Chinese court found him guilty of illegal medical practices and sentenced him to 3 years in prison. The court also imposed a fine of 3 million yuan, approximately $430,000, on Dr. He. 2 of his collaborators received lesser sentences and fines. The verdict sent a clear message that China was serious about enforcing its laws on human gene editing and deterring future violations. Dr. He's prison sentence, however, was only one aspect of the legal fallout. The case sparked broader discussions about the adequacy of existing regulations on gene editing worldwide. Many countries lacked specific laws governing germline editing, highlighting the need for international collaboration to establish clear ethical and legal frameworks. The Jiankui affair served as a wake-up call for the global community. It underscored the urgency of developing comprehensive regulations to govern the use of gene editing technologies. The goal was to prevent future abuses while fostering responsible innovation in this rapidly evolving field. Section 6. The global stage scientific and ethical tremors. The Jiankui affair sent shockwaves through the scientific community and beyond. It ignited a global debate about the ethics of gene editing, particularly germline editing, which alters the DNA of future generations. Scientists, ethicists, policymakers, and the public grappled with the profound implications of this technology. The case highlighted the need for a robust and enforceable international framework to govern human gene editing. While some countries had laws or guidelines in place, there was no global consensus on the ethical boundaries of this research. The lack of a unified approach raised concerns about the potential for rogue scientists to operate in countries with lax regulations. In the wake of the scandal, several international organizations, including the World Health Organization and the National Academies of Sciences, Engineering and Medicine, convened expert panels to develop recommendations for the governance of human gene editing. These panels emphasized the need for caution, transparency, and broad societal consensus before proceeding with any clinical applications of germline editing. The Jiankui affair served as a stark reminder that scientific progress must be guided by ethical considerations and societal values. It underscored the importance of engaging the public in discussions about the potential benefits and risks of emerging technologies. The global community recognized the need for ongoing dialogue and collaboration to ensure the responsible development and use of gene editing. Section 7. The CRISPR Promise, Eradicating Monogenic Disorders. Despite the controversy surrounding Dr. He's experiment, it is important to acknowledge the transformative potential of CRISPR/Cas9 technology. In the realm of somatic gene editing, where changes are not passed down to future generations, CRISPR holds immense promise for treating and potentially curing a wide range of genetic diseases. One of the most promising applications of CRISPR is in the treatment of monogenic disorders. These are diseases caused by mutations in a single gene, such as cystic fibrosis, sickle cell anemia, and Huntington's disease. CRISPR offers the potential to correct these genetic defects at their source, offering hope for millions of patients worldwide. Clinical trials are already underway using CRISPR to treat various monogenic disorders. Early results have shown promise in addressing the underlying genetic causes of these diseases. For instance, in sickle cell disease, CRISPR has been used to edit the faulty gene responsible for the production of abnormal hemoglobin, potentially offering a cure for this debilitating condition. While challenges remain in translating CRISPR technology from the laboratory to the clinic, the potential to alleviate human suffering from genetic diseases is undeniable. The ethical considerations surrounding germline editing should not overshadow the immense therapeutic promise of CRISPR in the realm of somatic gene editing. Section 8. The CRISPR peril, a slippery slope to eugenics. While CRISPR holds immense promise for treating genetic diseases, the potential for its misuse raises profound ethical concerns. One of the most significant fears is the slippery slope argument, which suggests that allowing gene editing for therapeutic purposes could open the door to genetic enhancements and ultimately lead to a new era of eugenics. Eugenics, the concept of improving the human race through selective breeding, has a dark history rooted in racism and discrimination. Critics worry that CRISPR could be used to enhance desirable traits such as intelligence or athletic ability, leading to a society stratified by genetic advantages. The possibility of designer babies raises concerns about exacerbating existing social inequalities and creating a genetic underclass. It also challenges fundamental notions of human dignity and the value of diversity. The ethical debate surrounding CRISPR highlights the need for careful consideration of the potential societal consequences of this powerful technology. Establishing clear ethical guidelines and regulations is crucial to prevent the misuse of CRISPR and ensure that it is used responsibly for the benefit of humanity. The goal is to harness the power of gene editing while safeguarding against its potential to exacerbate existing social divisions or undermine human dignity. Section 9, charting the future, regulation and ethical vigilance. The Jiankui affair stands as a stark warning. It highlights the potential for misuse of powerful gene editing technologies. The international community must respond with a two-pronged approach. Firstly, by establishing robust regulatory frameworks. Secondly, by fostering a culture of ethical vigilance in scientific research. International collaboration is crucial. Harmonized regulations can prevent a regulatory race to the bottom. These regulations should cover all aspects of gene editing, from research to clinical applications. Transparency, informed consent, and long-term monitoring are paramount. However, regulations alone are insufficient. A cultural shift within the scientific community is needed. This shift should prioritize ethical considerations alongside scientific progress. Open dialogue, public engagement, and robust ethical review processes are essential. The future of gene editing hinges on a delicate balance. The pursuit of scientific advancement must be tempered by ethical responsibility. The Jiankui Saga serves as a potent reminder. The power of gene editing demands careful stewardship. It requires a commitment to ethical principles to ensure its benefits serve all of humanity.